Welcome to Algeomulus Prep Academy.
Today we'll be learning about the limit definition of a derivative. This is one of the most important formulas in calculus, used over and over again, so be sure to memorize how to do it. This is the limit definition of a derivative. F prime of x equals limit as h approaches 0 of f of x plus h minus f of x all over h. Our example today is f of x equals 3x plus 5, and we have first we solve for the individual parts f of x and f of x plus h. F of x is 3x plus 5, and f of x plus h is 3 times x plus h plus 5, which simplifies to 3x plus 3h plus 5. We plug this in to the limit definition of a derivative formula, and we get f prime of x equals limit as h approaches 0 of 3x plus 3h plus 5 minus the quantity of 3x plus 5 all over h. You make sure to distribute the negative into the quantity of 3x plus 5, and then you simplify the terms. The resultant answer is limit as h approaches 0 of 3, which is 3.
So now we're going to work on a different problem. We have f of x equals x squared plus 9x plus 20 all over x plus 4. We're going to see if we can factor this out to make it more simple. So now we're going to put the last term at the top and the middle term at the bottom, and see what numbers add to the bottom and multiply to the top. In this case it'll be 5 and 4. So now I'm going to rewrite the equation using x plus 5 and x plus 4. And here we can see now that x plus 4 can cancel out to get just x plus 5. So now we're going to use our general limit definition. So f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. But first we're going to need f of x plus h. So it would be x plus h plus 5. So now we're going to take the derivative of this, and we're just going to plug it all in. So here it is. So now, as you can see, I'm simplifying it to what it should be, canceling out the terms that we don't need. And you can see that we were left with the limit as h approaches 0 of h over h. In this case, it would just go to 1. So the f prime of x will equal to 1.
For our final problem, we're going to be using f of x is equal to x squared plus 5x. And the limit definition is still the limit as h approaches 0 of f of x plus h minus f of x all over h. And f of x plus h in this problem is going to be equal to x plus h squared plus 5 times x plus h, which simplifies out to x squared plus 2hx plus h squared plus 5x plus 5h. And right here what we're doing is we're plugging in the limit definition. And then over here you can see that we plugged it in. So we have x squared plus 2hx plus h squared plus 5x plus 5h minus x squared plus 5x. And we're canceling out the x squareds and the 5x's. So what we're left with is 2hx plus h squared plus 5h all over h. And now you can see there's an h in all of them, so we can factor out an h from all of the terms in the numerator. And the h's in the numerator and the denominator cancel out. So what you're left with is the limit as h approaches 0 of 2x plus h plus 5. And now, what we're doing is plugging in 0 for h. And that gives you 2x plus 5. Thank you for watching our video, and we hope to see you soon. Keep calm and prep on.